This is AP problem number 14. Account for each of the following observations about pairs of substances. In your answers, use appropriate principles of chemical bonding and/or intermolecular forces. In each part, your answer must include references to both substances. For part A, it says, even though NH3 and CH4 have similar molecular masses, NH3 has a much higher boiling point, negative 33 degrees Celsius, than CH4, negative 164 degrees Celsius. And this is because NH3 has hydrogen bonding and London dispersion forces, and CH4 has just London dispersion forces. And since hydrogen bonding is the strongest type of force compared to London dispersion forces or dipole-dipole, it's much stronger, so therefore it has a higher boiling point compared to CH4 with just having London dispersion forces. For part B, it says at 25 degrees Celsius and 1 atm, ethane C2H6 is a gas and hexane C6H14 is a liquid. And this is because the intermolecular forces in both ethane and hexane are London dispersion forces only, but hexane has a lot more electrons compared to ethane. As you can tell by its formula, it's C6H14 compared to C2H6. And with more electrons, the molecule is way more polar, and the attractions between the molecules are a lot greater. So therefore, it has a higher boiling point compared to ethane. For part C, it says Si melts at a much higher temperature, 1,410 degrees Celsius, than Cl2, negative 101 degrees Celsius. And this is because in Si they are covalent, and since it is Si bonded to 4 other Si atoms in one structure, and chlorine is a non-polar diatomic molecule, the intermolecular forces between Cl2 and compared to Si are a lot weaker, and it would take less energy, and so it has a lot smaller boiling point because it requires a lot of energy to break the bonds of Si, and Cl2 only has London dispersion forces as its attractive force. For part D, it says MgO melts at a much higher temperature, 2,852 degrees Celsius, than NaF, 993 degrees Celsius. And this is because if you look at MgO, it has O, which is a -2 charge, Mg, which is a +2 charge, compared to NaF, which has a -1 charge and +1 charge. +2 -2 is greater than +1 -1, so it's going to have stronger forces and require more energy to break the forces between the ions.